Hello everyone, welcome to the episode 17 of this Deep Learning with Pytorch series. And in this video, we will try to do the hands-on coding where we will try to implement the concept of creating a validation and test set using a Pytorch data loader. Then we will talk about how to use a dropout and regularization in the code, and also how to check if there is any overfitting going on in the training process, and like we will try to fix that using the problem of overfitting using dropout and regularization, right? So generally these are like few boilerplate code which we discussed earlier also, so I will just skip this. And after that, so what the new thing which we are doing here is we will create a test set and a validation set. So we are downloading the train data. So we are still working on the MNIST data set, and using that MNIST data set, we will try to see where the overfitting is going on and how we can tackle that using the regularization technique. Right. So once we have our training and test data set, then we using this concept of data loaders. So in case you don't know what data loader is, so just check in this playlist. You will see there is a PyTorch specific data loader video which explains the concept in detail. So what we are doing is we are setting a batch size of 50, and we are mentioning that 20% of my training data set will be used as a validation data set. So we are pulling up the validation data set from the training data set, and we are keeping aside the 20% of my training data set as a validation data set. Right. So what we are doing is we are selecting the indexes out of we are checking what are the total number of indexes or the length of my training data set. Based on that, we are creating a list of indexes, and then we are kind of shuffling those indexes so that there is no if there is any pattern in the training data set, so that will be destroyed by shuffling those indexes, right? And then using this validation size, we are creating a split on those indexes, right? And on using that splitting criteria, we are creating train index and validation index, right? So once we have our train index and validation index, using this the subset sampler object, we will pass our train index and validation index, and we will create train sampler and validation sampler, right? So this two we will pass as a parameter to my data loader. So we will mention sampler equals to train sampler when we are creating the train loader, and using validation loader, we will use the sampler as valid sampler, right? And in case of test dataset, we are not doing any sampling. We are just using the test dataset as it is, right? So once it creates the batch, so then we can check the shape of a particular batch. So as there are 50 records in each batch, and if you remember, like we also discussed in the previous coding session, that these are 28 cross 28 images of handwritten digit, and for every image there is a associated label or target, right? So that's the shape of my test data set. Shape is also 50, right? Then without using a dropout or regularization, if we build a deep neural network, right? So why we are building the deep neural network? Because with using a deep neural network, there is a high chance of running into the problem of overfitting, and we will try to solve that using the technique called dropout or regularization, right? So we have four hidden layers here, and each of the nodes, like the number of nodes are mentioned here for each of these fully connected layers, starting from 1 to 5. And once we have that, we are not using any dropout in the forward function, right? So once we have that, if we use SGD as the optimizer and cross entropy loss as the loss function, then we will, if we just run this model and train this model, and we can also incorporate this new thing which is introduced in this code, right? So what we are doing is we are first turning off the gradient calculations. Then we are setting our model to eval mode, and then we are looping through in using the valid loader, right? We are looping through the validation data set and we are checking what is my loss in the validation data set. And for every iteration, we are kind of calculating the loss and appending to a list of in a list using this loss dot item, right? And after every epoch, we are checking what is my training loss and also validation loss. So this is how the output looks like. And if you look it closely, you will see that after 10 epochs, so till 10 epoch, your training loss and validation loss are quite close to each other and they are quite similar. But after 10 epoch, you'll see that your training loss is getting decreased, but your validation loss is still not getting decreased in a rapid manner. So here the loss is 0.005, but in case of validation loss after 25 epoch, the loss is zero point zero 0.08, right? So there is a overfitting going on, which we have identified by looking at the by comparing my validation loss with the train loss. Now, let's try to resolve this overfitting problem with the technique called dropout, right? So in case you are not aware what dropout is, just check my last video in this series and you will get a detailed understanding of bias, variance, trade-off, how we can tackle the high bias or high variance, and also the concept of dropout, right? So here we are introducing this dropout with a probability of zero point 0.3. And we are using this dropout in all the hidden layers and we are not using dropout at the output layer. So generally we don't use dropout at the output layer. We only use at the hidden layer, right? So what we are at first doing is we are like flattening our data set, which is like 28 cross 28. We are converting it to a stretched out vector of 784. Then we are passing it through a fully connected layer, which is FC1. Then we are using an activation function on top of it, which is ReLU, and then we are using a dropout. And every layer, for every fully connected layer, apart from the output layer, we are using a dropout, right? And after that, we will train our model. So you will see here the same things we are using. Torch.nograd, we are setting the model to eval. And if you also need to look into this model.train, right? So once this training process is done, your model will go into the eval mode, right? Or the evaluation mode. But again, you need to turn on the gradients and turn on the regular calculations, which happens at the forward propagation and back propagation level, right? So you are just setting your model to the train mode. So this is the command to set your mode in the train mode. And if you see now, your losses are quite comparable. Here at the end of 25th epoch, your loss in the training set is 0.05 and it is 0.07, which is much more closer while comparing with the previous iteration where there is a huge difference between your training and validation loss, right? Okay, now the few things which we included and we also talked about very briefly. Now let's discuss more on that, like what is this torch.nograd, right? So it impacts the autograd engine and it deactivates the autograd engine, so it will kind of reduce the memory usage and speed up the computations, but you won't be able to use the back propagation. If you use a torch.nograd, your model will not be doing a back propagation. So once we are in the validation loop or test loop, we will just enable this torch.nograd. So in those cases, your back propagation algorithm will be switched off, and also the autograd engine will be switched off. And your this model.eval, right? So this will switch off the dropout for validation phase. So if you remember from my last tutorial, so we only use the dropout in case of while doing the model training. In case of doing the inference, we will turn on the switched off or knocked out nodes of my whole neural network, right? So this model.eval will switch off the dropouts for validation phase, and model.train will bring the model again into training phase by switching on the dropouts, right? So these are the things which you should be mindful of, and which we introduced newly in this coding session. The torch.nograd, the model.eval, and model.train, right? Okay, now you can check accuracy on the test data set, and this is how we are also checking accuracy for each of the classes, right? So class-wise accuracy we are seeing, like, and we will see like some of the classes, like for handwritten digits which are like 7, there is accuracy drop of like it dropped to 96%, but there are certain digits which are like 0, for which the accuracy is 99%. So this is kind of gives you the class wise accuracy, which is always better to check. And the overall accuracy on the test data set is 98%, right? um, so this is how you can use dropout to tackle the overfitting problem. Now, the other thing which I talked about in the last video was L2 regularization, right? So it is very simple in Pytorch to implement this. So when you are creating your optimizer, you just need to mention this weight decay equals to 0.01. So if you remember, like we mentioned this lambda, which was part of the weight decay when we discussed the L2 regularization, right? So using this value of weight decay, you can introduce the concept of L2 regularization in the your whole neural network. So this, with this minor change, you can add also the concept of weight decay. So you can go ahead and try these things. You can incorporate dropout and as well as weight decay, and see how the loss are actually for training data set and validation data set or the test data set, right? So yeah, so that's all I have for this video. So I hope you like this one. So yeah, see you in the next video. Thank you. Thanks for your time.